Good morning students, welcome to our online video class of chemistry. In this video we will discuss about reactivity of 15th group element towards halogens and preparation of dinitrogen. Reactivity towards halides or halogens. Elements of group 15 form two series of halides of type EH3 and EH5. Trihalides, that is EH3, are formed by all the members of group, while pentahalides, that is EH5, are formed by all the elements except nitrogen. Nitrogen will not form pentahalide. And nitrogen does not form pentahalides such as NCl5 or NF5, etc. And what is the reason for that? Because it has no vacant d orbital in the valence shell. Atomic number of nitrogen is 7 and its electronic configuration 1s2, 2s2 and 2p3. So, there is no vacant d orbital in the valence shell. That is why it does not form pentahalides. And the last element, which is the last element of group 15, that is bismuth. Bismuth show less tendency to form pentahalide because plus 5 state is less stable than plus 3 oxidation state. Plus 5 oxidation state is less stable. So it has low tendency to form pentahalides. Bismuth shows low tendency to form pentahalides because of plus 5 oxidation state is less stable. And trihalides are covalent compounds except in the case of BiF3. The structure of trihalides is destructed tetrahedral of hybridization sp3. Trihalides have hybridization sp3 and its structure is tetrahedral, distorted tetrahedral. And the geometry of nitrogen trihalide is given in this picture. Then trihalides are covalent compounds except in the case of BiF3. All other trihalides are covalent compounds and they have pyramidal shape in gaseous state. Then ionic character of trihalides increases down the group. Down the group, ionic character increases. And trihalides hydrolyzed by water. And the ease of hydrolysis decreases down the group. For example, PCl3, that is phosphorus trichloride, undergoes hydrolysis. Gives orthophosphoric acid H3PO3 plus 3HCl. And the pentahalides are less stable than trihalides. Phosphorus form pentahalides in which phosphorus atom is sp3d hybridized. What is the hybridization of phosphorus in pentahalide? That is sp3d. And the important pentahalide PCl5, PF5, SPF5, etc. And PIFY does not exist The pentahalides have trigonal bipyramidal structure. We are going to discuss about preparation of dinitrogen N2. Dinitrogen is produced commercially by the liquefaction and fractional distillation of air. And the laboratory preparation are dinitrogen can be prepared by treating an aqueous solution of ammonium chloride with a sodium nitrate. That is ammonium chloride NH4Cl plus sodium nitrate NaNO2 gives N2 dinitrogen along with the water and sodium chloride. During the reaction, small amount of nitric oxide NO, HNO3 are formed, nitric acid and NO are formed in this reaction, and it is present as impurities in it, and these impurities can be removed by passing gas through the aqueous sulfuric acid containing potassium dichromate. How the impurities can be removed? Passing the gas through aqueous sulfuric acid containing potassium dichromate. And by the thermal decomposition of ammonium dichromate, we can prepare dinitrogen N2, ammonium dichromate, that is NH4 twice Cr2O7. Undergoes thermal decomposition, gives N2 plus 4H2O plus Cr2O3. Then and the very pure nitrogen can be obtained by thermal decomposition of sodium or barium azide, that is BaN3 twice gives, which undergo thermal decomposition and gets the pure nitrogen, Ba plus 3N2. And properties of nitrogen gas, that is N2 dinitrogen. Dinitrogen is colorless, odorless, tasteless and non-toxic gas. It is a non-toxic gas. It is colorless, odorless and tasteless. And it has two stable isotopes, that is N14 and N15. And its solubility, it has low solubility in water. And it is quite inert at room temperature because of high bond enthalpy of N triple bond N bond. Due to the high bond enthalpy of N triple bond N, it is quite inert at room temperature. And as the temperature increases, reactivity increases. At a higher temperature, the reactivity of nitrogen increases with increasing temperature. At high temperature, nitrogen combines with the metal to form ionic nitrides and combines with the non-metals to form covalent nitrides. At a high temperature, the nitrogen combines with the metal. When it reacts or combines with the metal, form ionic nitrides. When the nitrogen is combined with the non-metal, it gives covalent nitrides. And this is the example. Lithium, same metal, react with N2 gives lithium nitride. And magnesium, react with the magnesium is also a metal, react with the nitrogen, dinitrogen to form nitride of magnesium. Then N2 plus 3H2. Here nitrogen, dinitrogen react with the non-metal form ammonia. And this preparation of ammonia is called Haber process. Then dinitrogen combines with the dioxygen. It can only combine at a very high temperature, about 2000 Kelvin, to form nitric oxide. NO. That is N2 plus O2 gives NO, nitric oxide. The main uses of nitrogen gas are: it is used in the manufacture of ammonia and other industrial chemicals containing nitrogen. It is also found use where an inert atmosphere is required. And it is used, liquid nitrogen is used as a refrigerant to preserve biological material, food items, and in cryosurgery.